Now, what happens if the source moves really quickly? What happens when the source moves faster than the speed of the waves in that medium? So imagine that we have this supersonic jet here travelling at some speed v subscript s, s is for source again, which is faster than the speed of sound in that medium. We'll have a look at a simulation and then we'll do the maths behind it to show what happens. We actually end up with getting a shock wave. So this animation shows what happens when a object moves faster than the wave speed in that medium. You can see you get pressure peaks forming. This shows the same thing in 3 dimensions. So we saw in the animation that we get these pressure waves travelling along where all the wave fronts add together. So what we're actually interested in is what's this angle theta, which this wavefront makes with this horizontal line here. So to work this out, let's start with our plane at some point here at some initial time t0. Now, at some time t, this shows where the wavefront has gotten to. So the distance between here and here is given by vt. That's how fast this wave travels through the medium. Now, in the same time, the jet has actually travelled a bit further than that. It's travelled some distance here, vst. Now, you can see at that point, the jet's going to is going to continue to let out these sound waves. So we'll have the smaller circles centered on its path as it travels along. So we have a series of circles like this. And so if we want to work out the angle theta here, we actually draw a tangent from the point where the plane is up to this point here. And that angle in there is theta. And now we can use simple geometry. Because this is a radius and this is a tangent, the angle between those two are 90 degrees. So we can just use right angle triangle geometry. And so we know that sine theta is equal to opposite over hypotenuse. And so sine theta is equal to opposite vt over vst. And you can see the t's cancel out, so that's equal to v over vs. So we've now come up with an expression for sine theta, the angle that our shock wave makes with the path of the moving object, the source of the sound. So this animation shows the shock wave hitting the ground. When that wavefront hits you, if you're standing on the ground, you hear what's known as a sonic boom, which is why when there's a supersonic aircraft going overhead, you hear that boom noise. Now this is a very famous photograph showing a supersonic aircraft just hitting that sound barrier. It causes the water to condense around it, which is what you're seeing here. Okay, now we've had a look at this angle here and how to derive it. But one thing that you've probably heard of before is Mach numbers. So the Mach number is actually the inverse of this sine theta relationship. It's Vs, the velocity of the source, divided by V. And as we've just said, this conical wavefront here is known as a shock wave. Now you may be surprised to know, but you've probably actually seen shock waves before. When a boat goes faster than the speed that the waves travel through the water, you get a shock wave. So with this fast boat here, this speedboat, you can see the shock wave behind it. This photo here shows a bullet, and you can see the shock waves generated in the air as the bullet is going faster than the speed of sound in air. So let's do a sample problem now. So the question is, assume that the speed of sound is 343 meters per second. An aircraft travels at 410 meters per second. A, what is the Mach number of the aircraft? And B, what is the angle between the path of the aircraft and the shock wave? Okay, so to answer part A, the Mach number is equal to the speed of the craft over the speed of sound. And so that's 410 over 343. And so solving that, we have 1.20 is the Mach number for this particular aircraft. Part B then asks us to calculate the angle between, here's the aircraft traveling along and here's the shockwave. So we need to work out what's that angle in there. So we know that sine theta is equal to V over Vs. This is the inverse of the Mach number. It's 1 divided by the Mach number. So we could either put 1 divided by the Mach number here, or we can do it as 343 over 410. So we then solve that on the calculator. We take the inverse sine of this number, and this gives us theta is equal to 56.8 degrees.